Hello everyone, I am going to talk about data-driven medicinal chemistry using Python. If you have Anaconda installed, Anaconda hosts number of applications such as Spider, Jupyter Lab, Jupyter Notebook, so on. To open Jupyter Notebook, just go to CMD and type Jupyter Notebook. So go to CMD. It will open at the home page of Jupyter Notebook. Go to the new page. So this is a browser based application tool extensively used for data science. Now number of library I need to upload. So what I'm going to do, just copy and paste this all the library and paste it in this cell. So in order to work in medicinal chemistry field, need to import this RD kit, and from this RD kit import all the chem libraries. There are number of open source molecular database such as Campbell, Molpot, PubChem, so on. I am going to use Campbell database today to import new client from the Campbell web source. First choose one of the target, just write down the code. So VR1, this is vanilloid receptor involved in the transmission of pain. I have worked in this project number of years. You can use any other target you want to. So now I have to convert this target to a table format. So if you just see this target, you can see this is hard to read, this is not table format, so I have to convert to a table format. Now you can see first few row of the column. So here you can see all the target Campbell ID. I'm going to use this Campbell 4794 using this index 0. So from this target I will pull all the active molecule from the Campbell database. See, this is the target ID. This is the target I am going to use to pull all the data from the database. The code is news client dot activity dot filter target Campbell ID equals to target, and also I am going to filter only the IC50. Again I have to change this vr1 this variable to again like a table format. Data frame. Now we can see few of the column from the table, but this is still working. This is star means it is still working. We can see first few row from the still it is working, so I will get back to as soon as it's finished. Now you can see all the active molecule is pulled from the Campbell database. It has a smile column and also there IC50 and values. So if I check the shape, it has 3604 rows and 43 columns, and also you can check the columns. It will show all the 43 columns, so I will take only the relevant column to work with. I'll create that. I will take the column of activity ID, then canonical smile, and I'll take the type and then values. We can check also few row from the tables. Here is the tables, and now what you can do is, since this is one-dimensional string, we can put that new column here to make a structure draw from this canonical smile. So in order to do that, I have to first clean up the table. So first, if there is any value, none value, this has to be removed from the table. So we can do it that drop in a so now if we see the shape, see now it has 3516 columns, I mean rows. It was before 3604 rows, so it almost 100 rows eliminated from the table. So now we can introduce that molecular structure as a new column into this table. We have to use the pandas tool, add molecule, columns, column to frame. Smile to create the molecule. We can also check few row from the tables. See, now to running this add columns, we can get this molecular structure from these canonical smiles. So since we have the structure of the molecule, so we can drop this canonical smile from the tables. So we can write drop the column equals to canonical smiles. So we can see few columns again. Here you can see we have just dropped the smile column from the tables. So now since we have the structure of the tables, we can create the molecular weight for all this structure. So in order to do that, we have to write the code. Molecular weight descriptors dot molecular weight. We have to put it in a loop for I in molecule. We can run this. Now we can put to check again few of the row of the table. So now it created all the molecular weight and added into the new column into the tables. So now what else we can do, since this is we have the molecule and molecular weight, now we can check if this how many compound is following the Lipinski rule or not. So in order to do that, we have to create another columns. So we can create empty string and put the loop all this molecular weight and create the if else statement for I. If I is less than equals to 500, we can put the rules, different rules here. So if it is less than 500, then rules dot append following rules of 5, else rules dot append not following rules of 5. Okay, so we run that. Now this rules is actually list. I can show you. If you check the type, see this is a list. So in order to concat with the tables, I have to change this list to data frame. So now I can concat this new rows to the our main tables. So df2, you can say pd concat df and df1, and x is equals to 1, 0 for row, 1 for column. So if we run this df2, check few of those column from the tables. See, now you can see it makes all the column which is following the rules here. So now you can see all the column has molecule, the structure, the molecular weight, and how their status according to the rule of 5. So we just continue to build our database according to our requirement, and future I will introduce the different prediction of QSAR, toxicity, solubility, so on. So thank you for watching.